These are the solutions for the review for the final test, numbers 36 through 51. So let's take a look at our first problem here. And in this case, we are going to graph linear equations using the slope and y-intercept. Now, I use this method more often than I use any other method to graph lines, but the key is you have to have y by itself, and all of these problems here have y by themselves. And so this right here is our y-intercept. So this is where we're going to start. It's the y-intercept because if you set x equal to 0, you're left with just y equals -4. So we're going to end up going down 4 spaces, 1, 2, 3, 4, putting a dot there, and then using the slope. Now the slope is the number that changes x each time. So that's number multiplied by x each time. And so 2 is the number, so I can write 2 as a fraction as 2 over 1. So that tells me I'm going to go up 2 spaces, 1 to the right each time. Do that a few times and see how many points we can end up coming up with. And we could also go down to left 1, and that gets me on that line as well. And then from there you can draw the line between those points. And that is our graph. Let's take a look at our next one. Positive 3 is the y-intercept, so I'm going up 1, 2, 3, and using the slope. And the slope is -1/2. So this time you're going down, but then to the right. Notice that I went to the right because 2 is positive. Only one of the numbers is negative when we have a negative slope. Well, you could end up going up 1, but then you'd have to go 2 to the left to be on that same line. And that makes sense because up is positive, left is negative. And so once you've done that, you can draw the line between those points. Looking at the next one, just says y equals x. Well, if you don't see a number being added to x, you can always add 0. So that means that it starts at the origin. And the slope is 1 to 1 if you don't see the number out in front of x, it's just 1. So 1 to 1 means you're going up and then to the right each time. We could also go the other way, down to the left. Gets us on that same exact line. And then from there, we can go ahead and draw the line between those points. Looking at the next one, positive 1 is the y-intercept. This time the slope is -1, so that means you're going to go down to the right each time, down 1, right 1. You could also go the other way, up to the left, gets you on that same exact line. And then from there we can go ahead and draw the line between those points. Well, our next type of linear equations, actually they're inequalities this time, we're going to graph, are not necessarily in that slope y-intercept form, but we could put them in that form. So like on this one here, it's really easy just to move this 2x over to the other side. Now whenever you move a term to the other side of the inequality sign or equation or equal sign, it just switches signs. So in this case, it's y is greater than or equal to negative or positive 2x. It's going to be a positive 2x, and then it's a positive 3. Positive 2x because it was negative on the other side. So I go up 3 spaces, 1, 2, 3, put the dot, and then use the slope. And the slope in this case is 2 to 1, so I'm going up 2 over 1 to the right. Now I ran out of room going that way, so I should be able to go the other way as well. So down 2, left 1, gets you on that same exact line. Now before you draw any type of line, look at the inequality. It has the line underneath, so that means it's a solid line. And when we look at the inequality, it's y is greater. Greater values are above the line because the y values that are bigger are above. And so we would end up shading in this region here. The next one is good for xy intercepts. So when I set that up, I'm going to do 4x is less than or equal to 4, and 2y is less than or equal to 4. So when I go ahead and solve, I've got x is less than or equal to 1, and y is less than or equal to 2 when I do the division. And so I use xy intercepts typically when I come up with integers as x or y intercepts. And that way it doesn't become difficult having to graph a fraction of a point. So I go over 1 to the right, up 2, and then draw the line. Now it's a solid line this time. So I draw that solid line going through those points. And I figure out the shading. Now either of these values will give us the direction to shade. X is less than 1, less means to the left, or it says y is less than or equal to 2. Less than means down when I'm dealing with the y direction. So you can see either of the x or y values tells you which way to shade. Same thing on this one. Set up 2x greater than 6, so x is greater than 3. The next one you got to be careful with because it's a -3y is greater than 6. So y is less than negative 2 when I divide by the negative. So I plot those points over 3 on the x-axis, down 2 on the y. This time it's a dash line. And then when I shade, either will give you the same answer. X is greater than the 3, so greater means to the right when I'm dealing with x's, or y is less than negative 2. So less means down. So you can see either of them give you which direction to end up shading. So these values that I'm shading on this side of the line are possible solutions, are solutions for this inequality. So this next one, you could use slope-intercept form, but you could also just move the 2x over to the other side and get it in that slope-intercept form, which gives us y is greater than negative 2x plus 2. So go up 2 spaces on the y-axis, then go down 2, right 1. That gets you on that line. And then from that point, we could go ahead and draw the line. So it's a dash line again. Now when I shade, I'm just going to look at the y's. So y is greater than. Greater means above. So I'm going to shade off in this direction here. And that's where I end up going. Well, taking a look at our next problem here, it says determine whether a point lies on the line. Well, all you're going to do on this is just take your x value and your y value and substitute. So negative 6 times by negative 2 minus 1/4 times by 12, and see if it equals 9 or not. So we go ahead and do some work there. So the two negatives here cancel out to make a positive 12. Here it's a negative 1/4 times by 12. So you do the cross canceling, we're left with negative 3. And when I do subtract those two numbers, I do get 9. And so yes, this point is on that line. Looking at our next one, 1/4 times by 16 over 1. I wrote that as a fraction so you could see the cross canceling. Negative 2 times by y. Well, y is 5. And see if it equals negative 6. So here we do some reducing. We end up with 4. So 4 minus 10. Yes, those two numbers, 4 minus 10, does make a negative 6. So it does equal. So this is another yes. Substituting here, we have 12 times by 1/2. And then plus just 3 and see if that equals 16 or not. Well, half of 12 is only 6. 6 plus 3 is not 16. So when the numbers don't equal, that's when we say no, that point is not on that line. Look at our next one. We plug in the opposite of x. And so the opposite of x is going to be negative 6. And then we bring down the plus sign to 6. And 6 times 5. And see what we end up with. So negative 6 plus 30. See if it equals 24 or not. And so when we go ahead and do that subtraction, we do end up with a 24. And so when the two numbers agree, we say, yes, that point is on that line. Our next few problems ask us to write linear equations. And for a slope that is negative 1/3 passes through this point. So what we're going to use is the point slope formula. So remember, the point slope formula goes this way. Y minus y1 equals m times x minus x1. We substitute the point in for y1 and x1. So it becomes y minus negative 2 equals the slope, negative 1/3 times x minus 3. And so when we go ahead and do the work there, we end up having to add the opposite and then distribute that negative 1/3 over those numbers. So y plus 2 equals negative 1/3 x, and it becomes a positive because the two negatives there, positive 1 because I have to reduce. So just one more step and you'll have it in the slope-intercept form. So I want to subtract the 2 from all sides. And so when I do that, I have a y equals negative 1/3 x and then a minus 1. And that would be my answer there. Next one, same sort of thing. So y minus 1 equals 2/5 times by x minus negative 10. So again, that minus negative, remember that changes to plus positive. So when we distribute, we've got now y minus 1 equals 2/5 x. Now watch this one. 5 goes into 10 2 times. So that changes to a 2. 2 times 2 makes 4. So it becomes positive 4. And so from this point, all you have to do is add the 1 to all sides and you'll get your answer. So Our answer is y equals 2/5 x plus 5. And that is it. Over on this one, we have to find the slope first. So remember, our slope formula goes this way. Y minus y1 over x minus x1. So they're giving us more points than we need. So typically, I just cross off one of them, and I'll just take these 2 points. Now, remember, our y values go on top. So I'm going to do 6 minus 3 on top. Now, I started with the 6, so I've got to start with the 4. So 4 minus negative 2. So careful on that minus negative. Remember, you're going to add the opposite, so it becomes a 3 over a positive 6, because the minus negative becomes plus positive. So that just reduces down to 1/2. So 1/2 is our slope, and then we just pick one of the points. I'll pick this point right here, and then I'll substitute into my point slope formula. So it goes y minus y1, so it's 6, equals 1/2 times x minus 4. So go ahead and do some work underneath that radical sign, or inside the parentheses here. So we got y minus 6 equals 1/2 x minus 2. So then we just have the one step of adding that 6 to both sides. So when I add the 6 to the negative 2, I end up with y equals 1/2 x plus 4. So one more problem here, and on this one we need to, again, just cross off one of the points. So I'm going to cross off this bigger point this time. Just take these 2 values. So I'm finding the slope. So remember, I'm subtracting the y values first. So I'm going to do negative 7, take away 9. And so if I start with the negative 7, I've got to start with the 3. So 3 minus negative 5. So over here I'll add the opposite, so that way I'll make less subtraction errors or addition errors. That gives me negative 16 over, and then these cancel or make plus positive and make a positive 8. So negative 2 is what it reduces to. That's our slope. Now I'm going to take one of the points. I'll take this one and substitute into our point slope formula. Y minus negative 7 equals negative 2 times x minus 3. So when I do the add the opposite, I'll also distribute that negative 2. So now I've got y plus 7 equals 2x, negative 2x at that, because of the negative sign here, plus 6, because the 2 negative signs cancel out. And so one more step here. Just subtract this 7 from all sides. So I've got y equals negative 2x minus 1. And that would be my answer. So those are some problems on the review for the final test up through 51. Good luck on the others. Check out other parts for other problems.